Welcome to Module 5 of Programming in C. I'm your professor, Professor Fisk, and if you've liked these videos, please like and subscribe. They do wonders to let me know how this content affects you and how effective it is in your day-to-day, whether that's school or the real world. Otherwise, let's jump into it. So in this specific module, we're going to talk about memory allocation and pointers. In this micro lecture, we're going to discuss memory allocation. And by memory allocation, I mean memory addressing. So when a variable is created in C, it is assigned to a memory address. That memory address is normally in your random access memory. Now, why does this happen? This happens because A, we need a place to store the variable value, but we also need a place to store our computations and algorithmic outcomes that our processor derives when it's doing its specific computations. Now, this is really important because it's almost like when you're taking a math test, you have a scratch pad to actually do your work on, because there are certain situations where the math might be too intense. You might not have the ability to store that data in your mind and do the computation at the same time. This is also true for your computer. So when your processor is processing, it does use memory addressing on a very, very large scale. That normally happens at the L1, L2, L3, L4 cache level on your CPU, and then your random access memory. Normally the L1, L2, and L3 caches are used specifically for the highest prioritized computations. When you get to your random access memory, that's when you get into a situation where that information is normally application specific, and the memory that is in there in your random access memory is allotted. It is allotted to that specific application. Okay, so when I store a value in the RAM as a variable, I can do this, and you've seen this before already, where I say the data type int, the variable name my age is assigned the value of 43. This is perfectly industry standard. This in and of itself is an initialized variable the right way. We're not initializing it without a value. The value is on the right, and the variable name is on the left with a proper data type. But look at what's happening down here. We're printing, well, I want to print P, right? This is a form of int, I guess. Format specifier for int, for memory location. And I'm saying I want you to dump out the memory location via the reference operator of ampersand of this specific variable. So if I port it over to my C program, which I actually want to create a C program, and I want to call this module 5, and this is C, and we'll just make this very simple. Yeah, we'll say we have the printf there, so we will say int x. We're just going to give it an x coordinate, I guess, x coordinate of 15, and then I want to print that. So like I said, we're going to use a format specifier of p, and we're going to say ampersand x. And what should be printed is the memory location that sits in on my specific RAM, which is 0 times 7 FFE. This is a normal memory location. This is how your CPU sees memory on your RAM, in your RAM. Now, what's interesting is that is different, right? That is different than this. Notice it's different than what you, well, actually, it's almost the same, to be honest with you, but it's not. It's different. See, EB77C, EB7 Charlie, and if I come in here, that is not EB7 Charlie, which is a totally different memory location. Now, you might be asking, when in the world would I use this? Well, this is important because if we want to directly manipulate our memory allocation and our memory addressing to improve performance, to limit the amount of space that is used by our program, and be specific about how close our variables are in our applications, we would do this. But there's something else I want to talk about in a different micro lecture called pointers. So stay tuned. That's coming next. So as I say in all of my lectures, please like and subscribe. It really helps me to understand what content is relevant to you. Good luck. Have fun. Ciao.